Yeah. And I have like 90% certainty that this is what we're doing. I might be just totally blowing smoke, but it definitely looks like this is what's happening. It's a reference type, so it's referencing some underlying data type. So as I pass that, even if this, I pass the value of the reference type, this makes its own copy, uses it, right? It's a copy pointing to the underlying whatever, so it's referencing it. But here's proven a map is a reference type. So make a map, pass the map in, add something to the map, then try to access it, and I get it. It's cool. So that'd be the solution. How many people got the map to work? Awesome. Awesome. All right, so we left off with cookies. Some people left a little bit early on Tuesday. And if you left early, you could get caught up just by looking at the file server stuff. I think one of the highlights from file server, and this will be good review for everybody, is this weird chunk of code right here. Like, what? And when I saw this, I'm like, why do we have to do that, man? That looks totally obtuse and difficult. Like this line right here, right? Huh. Weird. Okay, but you got to remember kind of how how like RESTful apps work. This doesn't, when we ask for something, this doesn't correspond to folder directory structure. It doesn't correspond to files, right? We are handling everything through, programming logic. So if somebody asks for this, we just need to handle that. So here we have a handle, and if somebody asks for resources, and right here we're asking for something in resources, and since we have that slash right there, it matches all patterns, resources, and everything beneath it in the URL, right? So you ask for resources, this is what handles it. What is handling it? This right here. So we have this thing here that says strip off the prefix resources. So we just stripped this off, right? And that's what strip prefix is. If we go and we look at that, strip prefix returns a handler that serves HTTP requests by removing the given prefix from the request URL's path. Removes whatever prefix we give it from the request URL's path. So we've removed /resources from the request URL's path. That leaves us with this. Okay, and now we're going to serve files, and we're serving files from not our root, which would just be that, right? We only want to serve from a certain folder, which is assets. Okay, so from within assets, we're basically going to be tacking on, we're asking for this. Right? Show me that. So basically we're saying serve that one file, but we're catching everything in assets. And the slashes are a little bit, trying to remember what gets slash and what doesn't. But that's how that works. Right? And so I named these resources here just so you could see that that doesn't correspond to any folders over here on my server. There's no resources folder. That's totally fine. It doesn't have to map. In some ways, that might even be better. If somebody ever got your code, well, they got some of your code, but they don't know, your folder structure, right? So if they were trying to hack you or something, that'd just be like one more level of confusion for them. But the main thing is this does not correspond to any folders on here. It just says, okay, anything that comes in that path, I'm using this to handle it. And then I got, if these were all called assets, which they totally could be, right? That's fine. Now that really kind of looks like that would correspond to folder file path, and it does, which is right. But anything that comes in at assets here, I'm going to use this to serve it. If I didn't strip this from assets, I'd be serving from the assets folder, and what am I asking for from? So when something comes in assets, serve from the assets folder. What am I asking for from the assets folder? Well, that doesn't make sense. Assets, Toby, JPEG. All right, so because this is handled, that is handled right here, we don't want to give it another folder. That took me a long time to wrap my head around. Does not correspond to a folder on the server. Right? This corresponds to my route handling, my routing. That's it. That's where I use that. And now if I want to serve a file, right, I say, okay, I want to serve everything in this folder. Okay, you're serving everything in that folder. And when something comes in at assets, we'll serve it. What are we serving? Well, we got to take that off. So I kind of like having resources in there, just sort of like to, because if it's assets, 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 assets in all of these positions, right? And then that one too. It's like, So it took me a while to wrap my head around that. Hopefully I've explained it in a way that kind of is making a little bit of sense. Yeah? So that's one of the main...
If you didn't do strip prefix
Yeah.
on the second parameter on
Yeah.
the handle, what would it do? I mean, I know we can test it.
Yeah, no, I love the theory.
Logically,
It wouldn't serve anything. Let's do
You
it.
would need to have a folder called resources instead of assets.
Yep. Yeah. Yeah, I'd need that folder. So we could do that.
Oh, yeah, I see. I see how you get that.
And then we could put some other image in there called Toby, but some different picture. Serve. Things from your childhood stick in your head, don't they? That looks beautiful. Toby. JPEG. Watch this. This is going to take forever.
How deep can you go?
How deep can you go, man?
Which one
And
is that? FC.
99. Thanks, Bob. I don't even know what application I'm in. I'm saving a file there.
Serving files.
There. Okay, so I got Toby there. I got Toby here.
But you're still stripping.
I never strip in class.
I'm so relieved. I can't tell you. She's just going to show us the first way and then take it out.
I think I'm at like 9,000 or something. I should have stuck with 8080. I don't know where I picked up. Is that a cache problem? Let's look what's 9,000 do. Gives me this, and it asks for a resources Toby JPEG.
You're still stripping out. That's the point.
Oh,
You're
there we
still
go.
Stripping out the,
So I'm just going to take this out.
Yeah. So you're saying the stripping is another way to prevent, is a security feature?
I have not enough expertise to, but just thinking, right? Like, okay, there's one more level of obfuscation, and the more you obfuscate.
So that kind of assumes maybe somebody else is doing the HTML, they're handing it off to you, and you're writing the code to process it. So it's, because otherwise, why would you not just reference what is already there? I'm just trying to understand.
Yeah, also that middle parameter looks like, I don't know about the security stuff that much either. But it looks
Nobody says it that way.
It looks like maybe it would help from people like injecting extra stuff into the path, maybe, since it strips it. That's a good idea. I don't know what I'm talking about.
No, I think.
I'm trying to think of the reason. Yeah, I guess I could Google it and find out.
Go, it's crazy. It's cool though.
It's not crazy, but
It's crazy cool.
it's takes some time to understand the absolute perfect logic behind it. It doesn't suffer fools. And if you bang your head against the wall long enough, you will make a hole.
Really?
Sure. It might not be big enough to fit anything through it, But all right, so that's one of the takeaways from last week. Enough time on that one. Yeah, or from Tuesday. And then we also did the static file server. We saw that. So just a file server at root, then we don't have to worry about it. We don't have to strip anything because everything's going to root. So it is kind of serving, for a static site, right? We're not saying we're going into some folder, so we got to pull other things off the prefix. Sorry, man, I'm in class. So setting cookies, pretty cool. We have func main. Anything that comes in, we're going to set a cookie. We run that function. HTTP set cookie takes a name value and then a pointer to a cookie. Okay, so the cookie's address, HTTP cookie. There we go. So if we look at that in the docs, and I could bring it up this way, or I could go net HTTP cookie. And so we have a type cookie, and there's a function that will give us the string of it. And once we have a type cookie, what can we do with it? This is a set cookie, which right, takes a response writer, so it's going to write this back to the client. And it takes a pointer to a cookie. Well, here's type cookie and a pointer to a cookie. We also have that. So we just need to do it. Let's look at type cookie here. Type cookie is a struct. Has name, value, max age. So that's how we can make it expire. We can set the max age to less than 0. Then it means delete the cookie now. But name and value are two of the fields we're going to use. We don't have to set any fields we don't want to use. A cookie represents an HTTP cookie as sent in the set cookie header of an HTTP response or the cookie header of the HTTP request. So here's how set cookie works. Same thing as in the documentation, same description, right? But you also get to see a little bit of the code. Add the set cookie header to the provided response writer's headers. The provided cookie must have a valid name. Invalid cookies may be silently dropped, in which case my dog will gladly eat them off the floor.
What was that last one?
Invalid names will be silently dropped. Invalid cookies. This does not have enough chocolate in it. Yeah. Drop it. So that's it. So let's see what happens. If I look at, I think I close all this. If I look at localhost, what am I running at? 9,000. Clear my cache. I have something running. Then go into Developer Tools, Command Option I, or up here, more tools, Developer Tools, Command Option I. Launches up Developer Tools. Two places that we'll spend a lot of time looking is under Network. So when we make a request, brings back whatever was requested, and we can click on stuff, and we can see the request information, headers and things. I have no idea why it says requesting. Oh, I guess maybe it's asking for that. I don't know. And we could also look at resources, and we can see our cookies. I have no cookies there right now. So for my first cookie, I'm going to do my cookie, and the value will be Cookie Monster. So let's run that. And then I'll come back here, and I'll refresh, and I now have a cookie there. Let me get rid of that. Refresh again. There's my cookie. Q. There's a little piece of data stored on the client's machine. In Europe, if you use cookies, you gotta tell the user, by law, I'm using cookies. Is this okay with you? Okay. I think 98% certainty on that. That's what you've heard too. Yeah. So we could also, under the network, just see that. Come in here and see what happened. So because I had a cookie, when I made my request, it passed that cookie along with my request. When I requested this page, right? Because I just refreshed again, I already had the cookie. So my request, every request the client makes, if it has a cookie from that domain, when it makes a request to that domain, it sends the cookie along with the request. And then the server responded, and it gave me a cookie. Because this is how I wrote the server. You're getting a cookie with every response. So that's the response. That's the request. If I got rid of the cookie, and then I came back over here to network, and I request again, we will not see in the request a cookie because there's no cookie there now. I can't send a cookie. There is no cookie. But the server still responded, here's a cookie. Now if I request it again, because I have a cookie now, right, just got set right there from that last one. Now I send it back. So this is a way we can keep track of our users. We could put a unique ID in our cookie, and then we could use that unique ID to reference every user. And so there's something called a universally unique ID, a UUID, universally unique ID. And I've never looked this up, but universally, I guess I have looked it up. I always forget what I've done in my life. It's 128-bit value. And probability of duplicates. Out of 122 bits indicate that UID and 4 bits, 122 random bits, the chance of such UIDs having the same value can be calculated using probability theory, using the approximation. These are the probabilities of an accidental clash of calculating NUIDs with x equal 2 to the 122nd. So 2 to the 122nd. Is that big? I'm not even sure what that number is. That's times 36 tens or what?
10 to 36 power.
So that's basically 36 zeros. So 9 zeros is a billion. 9 zeros is a billion. Whoa. So there's that many possible combinations. So pretty improbable that you'll... So you give everybody a unique ID, and they set it in their cookie. You set it in their cookie. And you could go to godoc.org, and you could say, hey, I want a UUID. Is there anything like that in here? There's nothing from the standard library that I see. But here's one that we were using at summer boot camp. And we'll use that. You create a unique ID, and then just write that in every cookie. And then if the user tells me their name, I could store that in a database. And I could associate and their username and their password, right? And now I know that anytime I get a request with that cookie, it's this person. I could ask them to log in again if there's no cookie. And when they log in, I could write another cookie and say, okay, now this cookie, when it comes back, is associated with this account. I could pull out all their recent Facebook posts, if this was Facebook. I could pull out, their friends and what their friends' posts were. I now have the key to doing sessions, maintaining state, keeping track of people. That's how you do sessions. So let's see how there are some issues, that to think about, which we'll see in a second. So here we're getting a cookie. This is how we get a cookie. Request my cookie and then print the cookie. Let's see what the cookie looks like when it's printed to format print line. I'm kind of also interested. I was using this morning. And there'll be a chance for you guys to code. Just 1 second here. So that's what println and log did, the difference between println and log. And it gave me twice because I had 2 requests from the client. Client asked for localhost, and then client server, and then favicon. So it'd come back and show this little icon right there. So the client asked for both those. Favicon gets kind of asked for by default by browser. And so since 2 requests came in, each request, I'd written my code. Every time a request comes into here, run this. And so it got the cookie, right, that came in, and just printed out the cookie. And what it printed out was my cookie is equal to Cookie Monster. And I just tried log for hoots and giggles and take log out. But I found in App Engine I had to use log instead of println, format println. So now if I was to do the same thing, you wouldn't see the duplicate, right? You see 2 requests, but you don't see the logging one. So I want you guys to write a cookie and read a cookie. So there's the code on it. Muscle memory, just type it in, set a cookie, and then get the cookie.